All right, so this is section 7.5 in the Stewart textbook. We're going to be talking today about inverse trig functions. Okay. Now, inverse, a couple things on inverse. Okay, inverse is not reciprocal. Okay, it's not reciprocal. Reciprocal is 1 over, right? So a reciprocal trig function to sine of x is what? Do you remember? What's the reciprocal of sine? Cosecant x. The reciprocal of cosine is secant x, and the reciprocal of tangent is cotangent, right? Co, no co. Remember that? Those are reciprocal functions, and what we're talking about today is not the same as reciprocal functions. So that's first off. Secondly, inverse, I don't know if you remember from pre-calculus 30, but inverse means what? What's that little rhyme? Inverse means reverse, okay? Good, you remember that. So inverse means reverse. Now what are we reversing? Is it still frozen? Sorry. So inverse means reverse. And what are we reversing when we talk about inverse functions? What do we reverse?
X and y.
Yeah, the position of x and y. Okay? So if you take a look at sine x, and here's the graph of sine x right here, and we take a look at x and y. So the inverse trig function is going to be where x and y are reversed. Okay? Now that doesn't look much like a usable function for us, right? Because we're used to having y isolated and y by itself. So how do I get y by itself if I have x equals sine y? Do you remember how we did that? How did we isolate for this number or this, whatever this was? Remember, this is, if you think back, we're solving for angles, let's say, right? Sine of a equals 3 over 5. Remember that? How did we get a by itself then? How did we isolate? Well, inverse, yeah, inverse function. So remember we did second function sine? So I don't know if you can see this there, but on the calculator, and your calculator too, you'll have a sine to the negative 1. All of these functions are inverse functions of the buttons that you see. So the inverse of sine is sine to the negative 1 of x. So what we did here, and again I'll just rewrite this over here. What we did here to get rid of the sine part here, you can't just divide by sine, right? It doesn't make sense. But you take the sine to the negative 1 of this, and that means you take the sine to the negative 1 of this side as well. And this is inverse. It kind of looks like reciprocal, right? When you have to the negative 1 to the power of negative 1, right? I mean, in other things, like x to the negative 1, that means 1 over x. That means the same as reciprocal in some ways, but not when we're talking about the trig here. So there'll be some other notation we'll learn just to clarify that. But what happens here is we now have the sine to the negative 1 and the sine now cancel each other out. And we actually have y equals this, sine to the negative 1 x. And this is the inverse function. Okay? Algebraically, that's what it looks like. You have this little negative 1 there. Graphically now, when we reverse the x and the y, that means that every point on the original graph, and of course this original graph would be y equals sine x, right? Every point would be, the x and y would be reversed. So this right here would be approximately 0.5 and 0.5, it looks like. I mean, it's not, but it's approximately. So this is going to be pretty close to being the same point on the inverse. Let's take something that's not quite as obvious. So this one is about 1.5 or 1.6 and 1. You see that? 1.6, 1. So that means the new point is going to be 1 and 1.6, if that makes sense. It's going to be way up there. Okay. Let's take one more here. This one's going to be about I'm going to guess about 2.7 and 0.5. So now we're going to go 0.5 and 2.7. So this is going to be way up here. Now, we don't have the capability here to show this properly, but maybe you do on your sheet. But do you remember also when we talk about the graphic representation of inverse functions, do you remember how we did that just from the graph? There was something to do with this line of y equals x. Do you remember that? Yeah, so rotate it or flip it, a mirror image around the line y equals x. You guys remember that? Okay, so I'm going to see if I can do this here. That's going to be 1 there, so let's see. I'm going to try and make this y equals x line. The scale is not too friendly here. It's not too friendly to this line. It's going to be a little confusing. And there's a better picture in your book. Oh yeah, this is actually kind of tough to get those points. Oh, there we go. That's pretty good. That's pretty good right there. So that would be a y equals x, right? 1, 1. Negative 1, negative 1. Okay, it's pretty close. So we reflect about this line y equals x. And in order to save my drawing skills here are pretty bad, and this is not a very friendly function here, I am going to show you below, okay? I'm going to show you this page right here, and this is the sine graph in black, and this pink graph right here is the y equals sine to the negative 1x, okay? So you guys can go ahead and draw that in your notes, okay? I'm just going to show you this picture, okay? So it's a little bit tough, and this section right here in green is a special section. It's a little bit tough to see the difference because y equals x almost goes right through the graph there. But I do want you to write this down. These are different ways of stating the inverse of sine of x. Okay, so obviously sine to the negative 1 of x is what we've learned, but the more common, this is the one that I'm going to use most of the time, is arc sine x. Okay, arc sine x. So that gets away from the reciprocal sort of look of it, right? And this is this is what we're going to refer to most of the time. So arc sine would be the reflection about the y-axis of a regular sine graph. Okay. Also inverse sine or ASN, arc sine x, other ways of showing it. Okay? So is everyone okay so far? You with me so far? Inverse? Inverse means reverse. Flip the x and the y, solve for y. Now this isn't a function, is it? This inverse is not a function. It is, however, a function when we take a look at this special green part. Now I'm going to have to zoom in here a little bit, I guess. Okay? All right? But if you think about this green part right here is the part of, so from about there to about there, oh sorry, I'm looking at the black, forget it. Let me just fix that. I'll use a different color, and I'm going to use a red that's close to pink. So from about here, right, there, to about there, that is the domain for which this arc sine is a function. You see that? Because if we go past here, it doubles back on itself up here. If we go, from here down here, we got a problem too, right? So what we're going to do is we're going to focus on here to here, and from here to there. So this is sort of the screenshot of the arc sine that is a function. So when we say y equals sine to the negative 1 of x, it's only a function from negative 1 to positive 1. So it's a function when the domain is, and actually I think I have this started somewhere else. Yeah. Here's the new graph, kind of the next slide here for you. Okay? So arc sine is a function when the domain is restricted from negative 1 to 1. And if you turn your head sideways, you can kind of see that this used to be the maximum and minimum point, right? For sine, it's negative 1 to 1, right? So that's now the new domain. And the range, we have to restrict, okay, from here to here, and that range has to be restricted from negative, wait, let me just get my wits about me here. So from negative 1 to 1 and negative pi over 2, yeah, negative pi over 2 to positive pi over 2. Okay? So that's where, in this little box right here, that's where arcsine is a function. Does everyone see that? You guys see that? Okay. So if we think about the unit circle, remember the unit circle? This is negative pi over 2, and this is positive pi over 2. So we're looking at values sort of between here and here. Okay? So negative pi over 2 here. And this is positive pi over 2. And so it exists at all the values in between there. So all of these values here are good. Okay? Okay, we're good with that? I know we're not really doing much calculus right now, but 7.5, this is really just understanding what arcsine or the inverse of sine is. And then we're going to move to derivatives of the trig inverse functions. Okay, so let's see. I don't think I have your textbook up here just right now. So let's go to Calculus 30 text and chapter 7. Oh, here we go. I guess maybe I did have it up there. So if we just kind of go back here, I was going to show you. Okay, so here we go. See that right here? So these are two graphs. There's the portion of the, well, that's actually, yeah, that's a portion of the sine graph that we're inverting, right? Or we're taking the inverse of. So it looks like this. And that should go through 0, 0. It's just a printing error. So here's your domain. Here's your range. Okay? In order for it to be a function. All right. Also in your textbook, you'll see this right here, that sine to the negative 1x equals y. That's the same as y. Sine of y equals x. And of course, we're going to talk about this as arcsine lots here now. All right. So in working with this, so this section is just about working with inverse sine. And what I want you to remember is this. Okay. Okay. If you have any number, right, and you multiply it by what this would be like a function, or the function, this would be function to the negative 1, you get 1, right? So this is going to be something that I want you to keep in mind as we move through here and do our next examples, okay? So I just have a little note here. If you were taking notes, I guess you can take this if you haven't written this down already. Inverse functions are functions where the x and y have been exchanged or reversed. And graphically, it's a reflection about the line y equals x. So again, these are things that I've talked about, but if you want to write that down as notes, you can. All right, so we've looked at what an inverse looks like graphically. Let's talk about algebraically now, because this is sort of what takes a little bit of work sometimes. Okay, so if I asked you to find the exact value of this, I mean, certainly you could plug that into your graphing calculator, right? But let's think about this. We've done this before. We've done this before. But maybe you haven't, you're not realizing it right now. So in order to, okay, so let's say that y equals sine to the negative 1 of root 3 over 2. Now it's not enough just to plug this into your calculator. It's not enough to say the sine of root 3 over 2. It's not the same as that. But what we've done in the past in order to get rid of a sine to the negative 1, right, we would take the sine. Because remember, these are inverses of each other. Just like 5 and 1 over 5 could be considered inverses. You multiply them to get sort of the unitary value, right? So you take the sine of both sides. And this then becomes sine of y equals root 3 over 2. And this should be something that's familiar to you, right? This is when we looked at the unit circle, and we found out, hey, what value for y, or even theta, right? Remember we used to use that as theta or x or whatever. So what angle gives me a sine value of this? And so how you do this is you basically use this fact right here and take the sine of both sides. So does anyone know offhand what this is? Root 3 over 2? So here's 1. Here's 1/2. Yeah, we've got the unit circle up over there. You see which one's root 3 over 2? Okay, so cosine is the first one, and sine is the next one. So here's 1. So this is 1/2. This is 1/2. So you want to go over, and you want to go up to about here, right? So that you have root 3 over 2 is the second coordinate. So that matches with 1/2, I guess, right? And so this is, what's that one? Yeah, that one should be pi over 3. Okay? So y equals pi over 3. Okay? So why don't you guys do that one? Why don't you guys do B? You guys do B. Take a moment to do B and see if you can figure out what that is. Okay, so as you move through this one, you want to take the sine of both sides. And what do we have here? What value, again, what angle on the unit circle would give us a value of negative 1/2? And again, it's got to be between here and up there, right? So where is negative 1/2 on the sine side? I see it right there. So that's going to be what? Negative what? Yeah, it's going to be negative pi over 6. Okay? Very good. Okay? So let's move on. I got 2 more examples for you. 7.5 here. This right here, these ones are actually a lot easier than they look. They look really complicated, but when you take the inverse of its own function, it eliminates it, right? So I'm not really sure how much work I need to show you for this, but if you ever come across this where you have the inverse and this composition function, right? You have the inverse of this function inside the function, then basically these just cancel out, right? And so the answer here is pi over 4. If you have sine to the negative 1 of something here, while the sine and the sine of the negative 1 as a composite function cancel each other out. And then of course same thing here. Those just cancel each other out. Okay? Questions? That's pretty easy, right? Now I showed you that because I want you to be aware that you're going to come across something that looks like this. And this is a similar sort of thing, but we have tan and then sine to the negative 1. So they do not cancel each other out. Okay? But what you can do, and what I would suggest to do here, is to focus on what's inside here. Let's just save the tan of, let's save that for later. Sine to the negative 1, this is something that we can get a number for, right? So let's evaluate what's inside the brackets first. So if this is, y or theta, whatever you want to call it, right? Sine to the negative 1 of 3/5. You remember that this came from sine of theta or y or whatever of positive 3/5, right? So we just take the sine of both sides. And then you look at your unit circle. Okay. 3/5, is it on there? Ooh, okay, so 3/5. So we don't have 3/5 on there, so what do? It's not on there, so we might not be able to do an exact value then, right? Oops, that's not where I want to go. Okay, so sine 3/5. Could you plug this into your calculator? Well, I suppose you could plug this in your calculator, but it does say we want the exact value, so it's not a unit circle. What do we do? Now you may have a calculator that will give you an exact value by plugging it in. Not sure if that's cheating or not, but here's how you can think about this. Okay, so if it's not a unit circle and we were looking for an exact answer, watch this. Let's just pretend that this is our situation, and we have some angle that has an opposite of 3 and a hypotenuse of 5, and this is our theta here. Can you complete this right triangle? Well, we know that this is a 3, 4, 5, right? If we have a 3 and a 5 there, this has to be a 4. Pythagoras' theorem. So you could do 5 squared equals 3 squared plus x squared, x equals 4, okay? So now what does that tell us? Well, what's if sine of theta is 3/5, okay, what would be the tan of theta? Or could we find the theta there given that? If you got this situation, guys, here, I'll tell you what. If you've got this situation right here, you don't have to find theta first and then plug it into tan, because what we're looking for is we're looking for the ratio. We're looking for the tan ratio of whatever value this is. So guess what? We can relate it to this one triangle. I can do the sine and the tan and the cos all from this same triangle. So if if the sine comes from 3 and 5, guess what? The tan's going to come from 3 and 4. So the tan of theta is 3/4. So how do I combine this information with wanting a tan? Well, there you go. You just find the 4 and you can work from that situation. So let's see. The bottom line is there for that example 4, and that's in your textbook there, that the answer is just 3/4. Okay, and there is another visual there for you in your textbook, which I'll flip to here. So there it is right there. And so, of course, as you see, this is sort of what we've done. If you know that sine of y is 3/5, you can draw a triangle. And then from there, you can go, hey, I know what tan is of that same thing. And so that's what you're looking for there. Okay? Any questions? Why don't you go ahead and look through that section there and see if there's any questions, and then I'll give you an assignment here soon. Okay, it's worthy to note here that when you have sine to the -1 of sine of x, that equals x. It's the same is true for cos, right? And same is true, of course, for tan. So they, sorry? Yep, that's right. Yeah, it's the same as this. Now, what you have to be careful, guys, though, sorry, is that what I'm doing? Yeah. What you have to be careful of is the domains, though. Okay? The domains are different for sine. We know what the domains are, right? Negative pi over 2 to positive pi over 2. For cosine, this holds true for this domain, 0 to pi. And for tan, actually, I'll have to be careful with that. These, okay, so this, okay, watch this. This and this, they're both true, but they actually have slightly different domains depending on which one you start with. Yeah, because if you start with the sine and you put it into the inverse, you're going to have slightly different domains, which I will direct you to the text on that one. Okay? Because they've mentioned that for cos there. Yeah, so I'll direct you to your textbook there for the domains, but in general that does hold true still for X, but not valid over the entire domain. Okay. Okay, so here's your assignment 7.5, 1 ACE, 2 ACE, and I'll just go back to the textbook here briefly. So there's some visuals there on cosine, arc cos as well, arc tan, arc cos, so on. There's your different domains right here. That'll be on page 332. Okay. Okay, so just be careful with that. And tan's a bit funny there as well. So as you work with the tan, I don't think I have too many tans, but as you work with the tan, you have to be careful with your domain there. Okay. So 1 ACE, 2 ACE are what you can get started on, and there they are in the book.